Hello guys and welcome back to chemistry class. This is a continuation of our topic on the kinetic theory of matter and gas laws. And of course today we are going to be looking at, this is chemistry of course. And of course this is what? Gas laws. And today we are looking at Boyles law. All right, so today we are going to be looking at what Boyles law exclusively. This is what I'm going to see alone for this topic. Please know that this video tutorial is brought to you by the O3Schools JAMB CBT practice app. It has all the past questions that you need for it. In fact, everything you need for your exam to be successful is on the app. Another thing that will motivate you to go and download the app right now, right, is the UTME challenge. The UTME challenge is participated by students taking JAMB for the particular year. Right, so it's like a mock exam, right? It's like, in fact, it's set like your exam, like your real exam. You are competing with other students taking the same exam with you. You will see your score at the end of every week. Every week there's a UTME challenge. So when you participate, you see your score. And seeing your score helps you to do things. It boosts your morale, then it helps you to work on your weakness. So let's say your physics score is very low or your chemistry score is very low, then you know that you need to work on chemistry more. I spend more time with chemistry more, and then of course leave physics for a while. Not that you leave it totally, you don't leave anything totally, but you have to continually study them. All right, so it helps you to work on your weaknesses and boost your morale towards the exam, so that once the exam comes, hey, bye. All right, that is just all I'll need to tell you about the app. It is being displayed on your screen right now, and also activation is just 2,500 naira. Download it, activate it, and I'll see you at the top. So let's look at Boyles law. Boyles law is also called the Marriott law. Marriott law. All right. So Boyles law states that at constant temperature. So let me say Boyles law or Marriott law states that Boyles law or the Marriott law states that at constant temperature, right, the volume of a given quantity of gas is inversely proportional to its absolute pressure. All right, so I have to write this out for those who are taking notes. All right, so the Boyles law said that Boyles law or Marriott law said that at constant temperature. So in Boyles law, temperature is constant. That is the first thing you need to know. So at constant temperature, the volume of a given quantity of gas, right, is inversely proportional. It's an inverse proportionality. It's inversely proportional. So note two things. Temperature is constant and there's what? Inverse proportionality. So it's said that at constant temperature, the volume of a given quantity of gas is inversely proportional to its absolute what? Pressure. So this means that the law attempts to explain the variation between what? Pressure and what? And volume when temperature is constant, right? So the law attempts to explain the variation between temperature and between volume and pressure when temperature is kept constant. Temperature is kept constant here, while the volume, they say, is inversely proportional to the what? To the pressure. So mathematically we have that P is inversely proportional to what? V. All right. So this is how we represent it mathematically. P is inversely. The inverse of something is 1 over that thing. All right. So P is inversely proportional to what? To volume. All right. So now, if you want to introduce a constant, introducing a constant now, a constant K, for example, this means that what? If I introduce a constant, this sign of proportionality will disappear. All right. If you're introducing a constant, what? This sign of proportionality will disappear. It will no longer be available. It's going to what? Equal sign. So P now will be equal to what now? Let's say that constant is K, then over what? Over V. All right. So with this now, it means that what? If you cross multiply here, PV or K will be equal to what now? PV. P times V is equal to what? K, or K is equal to what? PV. So anyone you write is okay. And then this means that what? If you have, if the pressure what changes and the volume what changes, right? That means we have what? P1, V1 is equal to what? P2, V2. All right. So and so on and so forth. So of course you can use this formula to what? To solve for what? For question. This is very, very important, right? And this is very, very what? Equally what? Important for solving problems on what? On Boyle's law. So what you should know is that what? That at constant temperature, Boyle's law is keeping what? Temperature constant. Why what? They are varying what? The volume with the what? With pressure, and it's an inverse proportionality. All right. So P is inversely proportional to 1 over V, and if we introduce a constant K, P is equal to what? K over V. If you cross multiply, K is equal to PV, then P1 over P1 V1 is equal to what? P2 V2. These are very, very important. All right. This means that for a given quantity of gas, right, PV is what? Is constant. This is what it means. From this, it means that what? For a given quantity of gas, PV is constant. However, it is safe for me to let you know that this is only true for ideal or imaginary gases, right? However, I'll tell you that what this is only true for what? For ideal or imaginary gases. For real gases, like I told you, for a given quantity of gas, K is equal to what? PV, or PV is always constant, right? For a given quantity of gas. Like I said, it is only true for ideal or imaginary gases. It is not true for real gases. For real gases, it is not true. PV is never constant for real gases. For real gases, it is never constant, right? This means that what? Real gases do not obey Boyle's law at all. Real gases do not obey Boyle's law, right? So now, but for a real gas to now obey Boyle's law, what do we now do? Right? So real gases can obey Boyle's law under a condition. There's a condition that makes real gases obey Boyle's law. And what is that condition? It's an exam question now. Watch. If you don't know this, then you are playing. All right. So real gases only obey what? Boyle's law on the condition of what? Of high temperature and what? And low pressure. Right. So this means that for a real gas to obey Boyle's law, you have to subject that gas. You subject the gas to a very what? High temperature and what? And low pressure. Then if I've done this, PV will be constant. So for PV to be constant for a real gas, or for a real gas to obey what Boyle's law, the gas has to be subjected to a high temperature and low pressure. In effect, it means that what? Real gases only obey Boyle's law on the condition of high temperature and low pressure. All right. So now we have seen this, and of course I've explained totally that what PV is only constant for what? For ideal or imaginary gases, and I've told you the condition for real gases to obey what? Boyle's law. So we have to keep that at the back of your memory. This is a typical exam question. It's a typical exam question. What condition does real gases what? Obey Boyle's law, right? So if you know this, you know peace. All right. So make sure you put that at the back of your memory. Now, for an ideal gas at constant temperature, something is always what? Very, very noticeable, right? PV is what? Is constant. So let's see a table, for example. Let's say you have a table like this where this is P, that's pressure in unit. Let's say this is volume unit, and then let's say this is PV. All right. Let's say this is 1, this is 2, this is 4, this is 5, and this is 10, for example. And then of course this is, let's say, 20, then this is 10, this is 5, this is 4, this is 2, right? Now PV is P times V, right? Now 1 times 20 is what? When pressure is 1, volume is 20. 1 times 20 will be what? Will be 20 here. All right. When pressure is 2, volume is 10. 2 times 10 is what? Is 20. When pressure is 4, volume is 5. 4 times 5 is what? Also 20. When pressure is 5, volume is 4. 5 times 4 is also what? 20. And when pressure is 10, volume is 2. 10 times 2 is what? is 20. Now is plenty. Let's watch carefully. All right, now if you see here, when the pressure was decreasing, pressure here is what is increasing. Sorry, when the pressure is increasing, as you see, the pressure is increasing, then what? The volume is what is reducing here. P is 1, volume is 20. Volume is higher than pressure. When P is 2, volume is 10. When P is 4, volume is 5. When P is 5, volume is 4. When P is 10, volume is 2. So P increasing, volume decreasing. But what do you notice? PV is constant. It's constant. So what is noticeable here is that what? As pressure is what is increasing, volume is decreasing. And as what? Pressure and volume is changing. As they are changing, the what? The pressure remains what? Sorry, the PV what remains what? Constant. PV remains what? Constant, right? So I have said it before that PV is constant for what? For an ideal gas or for an imaginary what? Gas. So it's just a little illustration to show you the how PV what remains constant. All right. So now what I'm going to do, another important part of this lesson we are going to learn, of course, is the graphical representation of Boyles law. Let's see graphical representation. How do you represent Boyles law on a graph, right? On a graph. There are many ways to present Boyles law on a graph. You need to just know them. You need to know them. Because if you check your past questions, you can check your O3Schools JAMB app very well, you see that there are many questions like that. Which of the following graph represent Boyles law? Which of the following graph represent Charles law? So you must know the graphs so that you will be able to answer questions. Or then do not forget that this video tutorial, of course, is brought to you by the O3Schools JAMB app. Please do not forget to like this video. When you like this video, other students will find it easy to get across to our video. It will be easy for them to find the video when you like the video. So right now, please, as you're watching, click on the like button, that button that looks like this below this video. Just click on the like button, right? Of course, subscribe. Click on the subscription button. When you click on that red subscribe button below this video, it means that whenever we publish a new video, you will be among the first to know. You will get a notification on your phone that O3Schools has just published a new video. It does not mean you are paying anything here. So you are not paying anything to us. You are just subscribing to get notified, right? To also encourage us, because as our channel is growing, we get encouraged to do more. All right. Do not forget to also share this video to your friends. Share the channel to your friends and families that are preparing for this exam, also to your class group, to your classmates, and so on, so that they can also succeed with you. Now, let's head back to the graphical representation of Boyles law. So, number one, we have this. All right. This is pressure, this is volume. All right, then goes like this. This is what? A straight line. Oh, don't mind me. All right, so this is one representation, pressure and what? And volume, right? Showing inverse proportionality. And of course, number two, so another one, pressure, volume. All right, this is another representation for what? For Boyles law. Boyles law. Then number three, we have this. All right, then of course we have something like this going up there. Then here we have P 1 over V. This means that what? P is inversely proportional to pressure to volume. Then of course number 4, we have something like this. Here with V, here is what? 1 over P. Then this goes up. All right, so I think we still have other representations for this law. Let's say number 5 here. Number 5, let's have something like this. All right, like this, then like this, like this. This is a straight line coming down. So here is P or V, while here is what? Is PV. PV is constant. All right. The last one is like this. All right. All right. So this is what? PV here. Yeah, right here, P or V. All right. So these are what? The graphical representation of what? Of Boyles law. This is how we represent what? Boyles law on a graph. Very, 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 very what? Easy. All right. So as you can see, when the pressure or the volume is varied, PV remains what? Constant. And when P is what? You can see that P is inversely proportional to what? To volume in all of these variations. And of course, when P or V is varied, PV is constant. P of V is varied, PV is constant. All right, so you must take note of this graphical representation, as it will be very, very, very well helpful in exam settings. because you do not know where JAMB will set that question from in your time. All right, so it's not, it's just know what you need to know about a particular topic. All right, so now I'm going to take an example. We'll solve an example, but before that, I'm going to give you assignment. Before that, I'm going to give you assignment. Let me give you an assignment on this topic. So you go to your O3Schools JAMB app. Before we solve an example, please go to your O3Schools JAMB app, right, and source for this question after we are done with the example. But I'll drop the assignment now. Assignment. All right. So I'm going to have O3Schools JAMB app. All right. So go to Play Store and search for that. Look for 2000 question 6. Look for 1994 question 8. Look for 2005 question 33. Look for 2008 question 6. Look for 2010 question 5. All right. Then look for 2012 question 5 also. All right. So these are your assignments. These are just some of the questions sourced from the O3Schools JAMB app, right? So please make sure you attempt these questions. Now let's see an example to bring our point home. Sorry if I think that too fast. Just take the video back a little bit and you'll be able to see them. All right. Now I'm going to make this part very fast so that we can solve. All right, welcome back. Now we have a question before us. We're told that 280 centimeter cube of ammonia gas in a gas jar was observed to exert a pressure of 700 millimeter mercury. All right, now they said the volume occupied by the gas was increased from 280 to 400 centimeter cube. Determine the new pressure it will exert in atmospheric pressure, right? So now you're seeing in ATM, but one thing you should know from our formula, we have already seen. So let's say solution. So let me bring your memory back. Our formula, we have seen that K is equal to what? PV. And I told you that that means P1 V1 is equal to what? P2 V2. Right? So from the question, how do you even know that it's Boyles law? Do you see them make any mention about temperature here? No. So you're not saying anything about temperature here. You should know that they're talking about pressure and volume. So you should know that is Boyles law already. So now that means we're going to use this formula to solve. We're given V1. First volume is what? 280 centimeter cube. We're given V2. V2 as what? 400 centimeter cube. Remember in JAMB, you do not have time to be writing all this thing out. You don't have that nonsense time at all, right? You know V1, you know V2, all right? So you can just apply a formula straight. What are we looking for? Do you know what? We know P1. P1 is what? 700 millimeter mercury. But they want our answer to be in ATM. This is even why I brought out this question from the O3Schools JAMB. This is why I sourced for it, because you need to convert millimeter mercury to what? To ATM. And how do you do that? You simply divide by 760. So if you divide 700 by 760, it will now be in ATM. And of course, if you do that, that will give 0.921 ATM. All right. So please take note of that. Then of course, we're looking for P2. We don't know P2. So from here, from our formula, if we're looking for P2, that means P2 will be equal to what now? P1 V1 over what? Over V2. All right. So just make P2 the subject of the formula here. P1 V1 over V2. I cannot start showing you how to do that right now. So please make sure that you have a small knowledge about mathematics. Do not fail to do that. All right. So now let's go on. We know we're looking for P2. We know P1. P1 is what? P1 is 0.921 times V1 is what? You see V1 here is what? 280. All right. Then of course, divided by V2. V2 is what? 400. 400. So if you do this, all right, you break it down or press your calculator straight. You don't have time for all this rubbish. Press your calculator 0.91 times 280 over 400. Answer should be 0.645 ATM. All right, so this is very, very simple, but the catch here is this: it's converting from millimeter mercury to ATM, and you should know it here that to simply convert from millimeter mercury to ATM, you simply divide by what? By 760, and you are done. All right, so please, this is just a simple what example. Is very easy example. I give you an assignment. Please make sure you go to the O3 Schools JAMB app and source for them. All right, please do not forget to subscribe to this YouTube channel, and my name remains MCO Woblo, and I will see you definitely in the next class. Thanks for watching.